today you learned about how to figure out the turning points of the polynomial function and what turning points are. Okay, so in number one, we want to fill in all of the information about the graphs that we have here. So the number of x-intercepts, you can count them. This is 3. Okay, number of turning points, obviously it's going to be 1 minus the number of intercepts. So that would be 2, and you can see them. Turn to 2. The x-intercepts. Now, these are not pretty, and when they're not pretty, we don't want you to estimate. You can just say between -1 and -2. There's one at 0, 0, and then the next one is between 1 and 2. Okay, so there are 3 of them right here, right here, right here. Okay. Your local maximum, again, we're going to have you kind of estimate. This graph is ugly, so your max and your min, we're going to let you estimate over. So the local max is right here, and that's going to be -1, comma, 1. Look at your scale. Okay, notice that every 2 of them is 1. So this isn't 1, 2. This is 0.51, 1.52. Okay, so -1, 1. And then your local min, same thing. It's going to be +1, and make sure you look at your scale. It's at -1. So then I want you to give the interval where it's increasing. So it's obviously increasing from -infinity, okay, all the way to right here. Now, when you give these numbers, you're always giving numbers off the x-axis. So that's going to be from -infinity to 1. And then it starts increasing again from here over. So that would be from 1 to infinity. Okay? So there are 2 places where it's increasing. And then there's only 1 place where it's decreasing, and that's in between these 2, from here to here. Okay, so that would be from -1 to +1. And these are all going to not be including, because the turning points are an actual point. So you don't include, you're going to use parentheses for those. All right, number 2, number of x-intercepts. There are only 2. Your turning points, there is only 1 turning point. I know it looks weird, but this is a weird graph. There's like this plateau right here that's not considered a turning point because it's not increasing, it's not decreasing. X-intercepts, we've got 2 of them. They are between -1 and 0, and then between 2 and 3. Okay, the local max is right up here, the top part of the graph, and we're just going to estimate on that. So that is 1.5, comma, 3.5 about. Okay, your local min. There is not a local minimum on this one. There is not a local minimum. It is not this point down here. This is all increasing along here. This is like it's called a plateau. It's like a saddle almost is what they call it when you get to calculus. You'll hear about that. And this is actually continuing to increase. There isn't a drop and then an increase again. So this is kind of an unusual little graph that we gave you. So there is no local min. Increasing, it's increasing from -infinity up to 0, so up to this point right here, and then again from 0 to 1.5, which is from there to here. So this is increasing right here. We're going to stop there because that's where the saddle is, and then it's increasing again right here. So you've got 2 places where it's increasing. But at 0, it plateaus, and it has this saddle point, which is what they call it. And that saddle point is going to keep us from just saying -infinity to 1.5, because this part right here, it stops it. So you have 2 different places where it's increasing, but it's not decreasing in between those 2 places. It's just kind of a plateau. And so then decreasing, it's decreasing from 1.5 here. It's decreasing from here all to infinity. So from 1.5 to infinity. Okay. Number 3, plot the graph by using the intercepts, and then we're going to ask for the intercept, the y-intercept, and the indicator. Okay, so this is a bounce right here. So 1, 0, 3, 0, and then at -1, this is like a bounce right there. The y-intercept, you're going to put a 0 in for all the x's. So if I do 0 plus 1, that's 1 squared is 1. 0 minus 1 is -1. So we have 1 times -1 times 0 minus 3 is -3. So this becomes 0, comma 3. And the end behavior, this should be a fourth degree because you've got two x's here, an x here, and an x here. So there are 4 x's in this problem, which means it's a fourth degree polynomial. So, and the coefficient in front is a positive. So these should both be up. So your graph is going to be a W shaped, but it's not going to cross here. This is going to bounce. It's going to come up and come back down. It's going to cross, and then it's going to cross again. So something like that. Okay.